Here we have midterm exam 1, problem number 6. A metallic sphere with a radius r1 is charged. So the electric potential on its surface is 3.85 volts. Then the sphere is surrounded by a metallic hollow sphere with a radius r2 and a zero initial electric charge. The sphere is electrically connected for a short time. Find the final electric potential at the surface of the inner sphere. Now, first of all, let's divide this thing into parts. Okay, in the first part, let's say in the first part, we can see that we have a sphere, okay, with R1 and it's charged. So let's say it has a certain charge with Q. And electric potential on this charge is V1. Okay, now then it's surrounded by another sphere with R2, and the R1 sphere is connected by a wire, and when it's connected by a wire, what happens? All the charges on the R1 or the first sphere will go out and reside on the bigger sphere, okay, as you can see here. Now then we have to find what is electric potential at inner sphere. This is V outer sphere, okay. Now before solving let's first look at the little bit on the theory, okay. Now suppose we have here a charged sphere, and if you want to draw the electric potential on that one, then we know that since the charges will reside outside of the sphere, electric potential inside the sphere will be a zero, okay, as you can see here. And then it will be maximum on the surface of the sphere, and then it starts going down or decreasing by the formula where electric field is equal kq divided by r squared. So that means we can say that electric field is proportional, inverse proportional to the 1 over r squared, okay. But however, in the electric potential, this is, so first case was electric field, then in the second case electric potential will be maximum inside the sphere, and then it will start decreasing by the formula where V is equal kq over r. So that means electric potential starting from the surface of the sphere will decrease proportionally by 1 over r. Okay, I think this is clear now. This is the charged sphere, conducting sphere, okay. Now that means first of all we have to find in the first case okay, this is the first case where V1 is equal kq divided by the R1, correct? So then we can say that the charge doesn't change, okay? So kq is equal V1 times R1, okay? Now when you connect it to this outer sphere with a radius of R2, what happens? All the charges will leave the smaller sphere and go and reside on the outer sphere, okay. But however, as I said, the electric potential inside the sphere will be the same, okay. So that means we can say that V outside is equal V inside, okay, or we can say V2 is equal to the V1 inside, and then it will get less and less outside of the big sphere. That means if that's the case, then we can say that we can find what is the V2 here. So the V2 is equal to the kq, the charge is constant, then divide by R2, correct? So that means we found, okay, we have got this formula. Then after that, V2 is equal kq is equal V1 R1 divided by the R2, okay. Now if you plug the numbers, then you get a certain number. That means V inside is equal to the V outside, okay. That means V1 is equal to V2. Once you get this number, then you can say that V inside or outside is the same, so therefore you should get the number, okay. So this will be the this is a before, and this is after connection. After connecting, and then all charges will move to the outer sphere.